When we look up, we see a story. The stars, the nebulae, the slow drift of galaxies. They are pages in the biography of our own cosmos. We can trace it back 13.8 billion years to a single searing moment. But what if that origin story is incomplete? What if our universe is not the first edition, but merely a recent volume, bearing within it the unerasable scars of a world that came before? What if the death rattle of a forgotten reality was the very spark that ignited our own? Today, we are not just looking back in time. We are becoming cosmic forensic detectives. Our case file is the oldest light in existence, and our prime suspect is a comet. Our story begins not with a whisper, but with a silent, icy scream from the void. In 2019, a blur of light and gas pierced the orbital plane of our solar system. This was 2I/Borisov, only the second interstellar object ever detected. It was a fleeting guest, a wanderer from a star we will never know. At first glance, it was a relief. Unlike the bizarre, cigar-shaped Oumuamua, Borisov was comfortingly familiar, a classic comet with a nucleus, a coma, a tail. Its light, broken into a spectrum, showed the telltale signatures of water vapor, cyanide, carbon monoxide. It was, scientists declared, strikingly similar to the comets of our own solar system. An alien, yet strangely familiar. But in science, familiarity can be the ultimate camouflage. For years, the data from Borisov's passage lay in digital archives. It was a solved case, until a team of researchers armed with new algorithms and a nagging suspicion decided to look again. They sifted through the spectral fingerprints from the mighty, very large telescope in Chile, not for what was there, but for what shouldn't be. And there, buried in the noise, they found it, a ghost in the machine. The signal was faint but unmistakable, an anomalous, powerful signature of nitric oxide, NO, and not just a trace, an abundance that defied comparison. In the comets of our solar neighborhood, such a concentration is virtually unseen. It was a chemical scream from a foreign shore. This was not a mere variation. This was an impossibility, a fundamental break from the cosmic rulebook we thought we understood. It was like finding a perfect, polished gem embedded in a piece of primordial bedrock, an artifact of a different making. The man whose work gives context to this anomaly is not a comet chaser, but a titan of theoretical physics, Sir Roger Penrose, a Nobel laureate who helped map the terrifying geometry of black holes. Penrose proposes a theory so audacious it reshapes eternity itself, Conformal Cyclic Cosmology, or CCC. He posits that our universe is not unique. It is one aeon in an endless, infinite chain. There was no singular beginning with a capital B, only an eternal, cyclical rhythm of death and rebirth. Here is the staggering consequence of his vision. Imagine the far, far future of our own universe. Trillions upon trillions of years from now, all stars have burned to ash. All black holes have evaporated in a final sigh of Hawking radiation. All that remains is a vast, silent, featureless sea of low-energy photons, a cosmic blank slate. And here is Penrose's brilliant, mind-bending twist. In this state of maximum entropy, the very concepts of scale and temperature become meaningless. An infinitely large, cold, and empty end is mathematically identical to an infinitely small, hot, and dense beginning. The end of one universe becomes, with perfect, inevitable symmetry, the Big Bang of the next, the ultimate, inescapable recycling of reality. But a grand theory demands tangible proof. and Penrose provided a testable, breathtaking prediction. If a previous universe existed, it too had its titans, supermassive black holes. At the end of time, as these monsters evaporated, they would have unleashed spherical tsunamis of energy, their final, definitive death cries. Now, envision the next universe, our universe, being born from the ashes of the old. That colossal, structured energy from a dying black hole would not simply dissipate. Think of it like a thumb pressing into a balloon. The dent on one side creates a protrusion on the other. In the same way, Penrose argues, the shock wave from a black hole's death in a previous aeon would have left a permanent, circular imprint, a cosmic fingerprint, on the infant fabric of our universe. He calls these imprints Hawking points. And this is where our cold case from 2019 reopens with explosive force. The anomalous chemical fingerprint in Borisov, that overabundance of nitric oxide and exotic chemistry, could be read not as a quirk of formation, but as a localized echo of a Hawking point. The comet, born in the outer reaches of its alien star system, might have condensed from material that was fundamentally imprinted or irradiated by the remnant energy of a black hole death from a prior cosmos. We are not just looking at an alien comet. We might be holding a piece of a cosmic tombstone, a fossilized fragment of a reality that ceased to exist before our own first moment. This is where the story fractures. The scientific mainstream has not embraced this idea. For most astrophysicists, extraordinary claims require not just extraordinary, but unassailable evidence. Their argument is rooted in statistics and psychology. Stare at any complex, noisy dataset, the static on a dead TV channel, the swirls of marble, and your brain will insist on finding patterns. Faces, animals, shapes. This is apophenia, the tendency to perceive meaning in randomness. Critics contend this is precisely what's happening. In the vast chemical noise of a comet spectrum, it is statistically inevitable that some unusual ratios will appear. It is pareidolia on a cosmic scale. Furthermore, teams have rigorously reanalyzed the Borisov data. A recent major study concluded, while the chemistry is distinct, it remains within the plausible range of protoplanetary disk variability. We find no need for physics beyond our standard models to explain the composition of 2I/Borisov. For them, the case is closed, a fascinating oddity, but not a portal to a previous universe. So who is right? The visionary connecting comet dust to the death of cosmos, or the meticulous custodians of established chemistry and statistics? The profound truth is we do not know, and that is the electrifying power of this moment. This is no longer just about a single interstellar rock. It is a clash of paradigms. It forces the ultimate question upon us. Is our existence a solitary, finite event in an otherwise silent eternity? Or are we merely the current chapter in an infinite, cyclic epic, where every ending is woven into the foundation of a new beginning? If Penrose and this bold interpretation of Borisov's anomaly are even fractionally correct, it would be the most humbling and revolutionary discovery in history. We would have not just a history, but an archaeology of existence. Our universe would have a family tree, its roots twisting back through an endless succession of deaths and rebirths. Right now, it remains the most breathtaking of hypotheses, unproven, fiercely debated, radiant with ambition. It reminds us that science at its cutting edge is less about finding final answers and more about learning to ask questions so profound they shake our understanding of reality itself. As a new generation of observatories, like the Vera C. Rubin Observatory, turns its gaze to the sky, it will find not one, but dozens of new interstellar visitors. Each will be a new piece of evidence, a new line in this cosmic cross-examination. We are no longer passive observers of the heavens. We have become detectives sifting through the ashes of time, listening intently for the faint, lingering echo of a world before our world, searching for our own cosmic ancestry in the chemical whispers of wandering stars. The ultimate question is no longer just, are we alone? It is, have we ever been the first? What do you think? Is this the first hard evidence of a cosmos before our own? Or are we, in our desire for a grander story, simply seeing shapes in the interstellar static? Let us know in the comments below. And if you want to join us as we investigate the next great cosmic mystery, subscribe now. Thanks for watching.